how would you do it? What's your approach? And the first thing I'm going to ask you is, how many loops are involved, and what's the relationship of the loops to each other? Are they one after the other or one inside the other? Yeah, so 1 through 6, 7 through 11. All right, now remember what we had learned earlier in the semester is if you have a hard problem, don't try to solve the hard problem. Think of an easier problem that's related to it or similar to it and solve that one first. What would be an easier problem than this that's similar to it that you've already done? What does that look like if you squint?
Pattern triangle.
Right, but you've not done triangles, but can you imagine something similar to this that's simpler to do that you have done? Yeah, just a solid rectangle, or a square. So just imagine that these lines are all full and not cut off at that side. So, how would you do the solid rectangle? Like how many loops? And what does the inside loop do, and what does the outside loop do? We've done this, haven't you? You've done solid rectangles. How did you do it? How many loops? So one loop gives you a line, so it can't just be one loop. Yes, yes, what? You're killing me.
6.
Yeah, 2 loops, one inside the other. The inside loop is the line drawer, it draws a horizontal line. And the outside loop tells the inside loop what y coordinate to draw the line at. But, and then, you know, that's pretty straightforward. You have 2 for loops, inside for loop draws a horizontal line, the outside for loop tells the inside for loop what y coordinate to draw it at. Then, once you've got that much, how would you adjust that program in order to get this effect? See, what's being changed, the end point or the start point? Start point. All right, so let's see here. This is point patterns 2. There we go. Problem 1. Let me make it bigger so you can see it. All right, here it is, just right in front of me. So it's a loop within a loop. I'm still passing in, you know, the lower left coordinate and its width or height, and then what point count should start at. And again, these numbers aren't just like off the top of my head. We have like a 1 and a 1 and a 6 and a 1. The first one is assigned to this variable. The second one is assigned to that variable. The 6 is assigned to this length of side. And then the last one's assigned to point count. These are what those numbers get assigned to when the procedure's called. So, this is just a loop within a loop, but there's a trick here. And the trick is to do what? Yeah. So in the loop that draws the horizontal line, where it's trying to find the left side of the figure, the left side of the rectangle. So the left side is lower left x. But if I would just say and add whatever is an x offset to it, it starts off at 0, so the first line is not cut short, is not started to the right of where it should be. So you get a full line here. But notice, what does the plus plus do here? Adds 1 to it. So then the next time through this for loop, we're going from lower left x plus 1. Hence, lower left x plus 1 gets us here. And then the next time through the loop, it's lower left x plus 2 and so on. So this is interesting. You know, once you have the fundamentals of this programming kind of down, you can add little things in there to mess with it, to get these different effects. And so this is, you're going to see a lot of this offset type stuff just to get these effects. There's one. All right, how would you do this one? Yeah, it's the exact same idea, except you're going backwards, but instead of this, like we're starting on the right this time, and yeah, it's the end. The end's on the left. The end is on the left here, but we're messing with the end point with an offset. Yeah, once you see the trick, it's not so bad. All right, how many loops and what's the relationship to the loops, to each other?
Count as one.
Well, it's interesting because it's not solid. Yeah, it looks like it's, you know, there's a line, and there's a line, and there's a line, and there's a line, right? So this is 2A. Let's take a peek at 2A here. How many loops? 4. Yeah, so what's happening is because it's not solid, this is just 4 lines with one loop per line on that one. Yeah, we're just going the other way around on that one. Yeah, this is tricky, but not too tricky. So what's happening is that we plot this point, and then we jump up here and plot, there's 2, and then here's 3, and here's 4, here's 5, here's 6. Now, and same thing's kind of happening here. 13, 14, 15, 16, 17, 18, 19, 20. Now, the trick here is the simpler idea. I'm just going to draw a line. One loop, one line. But while I'm drawing the line down here with this y coordinate, while I have the x coordinate of this at this low y coordinate, can I also in that same loop just put in another y coordinate like pops up here and use that same x coordinate up here and do this one. And then come back down here, plot that one, and then in that same loop just jump up there and do that one at the same x. And that's what these do. Which one is this?
Wouldn't this be the 2 loops, one for up and down?
Yeah.
Left, right, huh?
I think you're seeing it. So let's hear, this is 3A. So this for loop draws the bottom and the top at the same time. So it'll at the current x index, it'll draw it like lower left y is the bottom, and then it'll just go lower left y plus height minus 1 to do the same x, because in this loop, you know, I'm moving x from a low value to a high value. While I have that x at whatever x it's at, I can also pop up to the top of the square and plot the coordinate that's above it at a different y. And then so that's what happens there. And then we could also do it with the left and the right. You know, while I'm drawing on the left, I can just keep popping over to the right. This, you know, this one has a hint. What you could do is copy the hint in and uncomment the delays and just watch it do it. It's really interesting. All right. This is probably the trickiest one.
So it's going with the corners.
Yeah. 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay. This one is also just using an offset, but it uses it in a very unique way. I'm just going to give you a peek at it.
3B. So this is something that because you came to class, you get this hint. Where for the people that don't come to class, they don't get the hint. So I'm still using an offset, but I'm moving the offset. The offset starts at 0. And while it's less than or equal to size minus 2, increment it. And then what happens is that I'm drawing the bottom line, and the offset is being added to the x. And then I draw the right line, and the offset is being added to the y. And then I draw the top line, and the offset is being, added to the x again, going backwards. And then the left side. Yeah. This is just to show you that you can, with creative thinking, do a lot with these offsets. That was probably the trickiest one. All right, now, this is where you break the problem down again. This is a hard problem to draw all those. What would be a simpler problem?
Do one at a time.
Just do one. So what you have, actually from a previous problem, is just a procedure that draws a solid rectangle. But then how do we do this?
Is that using the offset then?
Yeah, and in fact, let's see here, this one is 4A. You're going to like these, I think. So there's our solid rectangle drawer. You can just copy that in from a previous program. Now, where the tricky stuff is happening is in the main procedure. Can I just call the solid rectangle procedure over and over again? But what am I doing with what I'm passing to it? So every time I call it, the x and y of the lower left corner is different. I'm passing a different lower left corner. And that's the main thing that's different. Well, how am I changing the x and the y here? Well, here's how I'm changing the x. X starts at 1, and while it's less than 30, inside these curly braces, which you didn't have to do it here, and you didn't have to use a for loop, you could use the while loop, but what am I doing with x index every time through the loop? Add 6 to it, and then what am I doing with y index? Add in 3, and just by that little bit of playing with it, you can just call that procedure over and over again, and there you go.
And that's this one.
Yeah, same thing, it's just, we're starting, the lower left is started higher, and then we go down in the y. But the x is still the same. It's the y that's been changed there. And this one? Oh,
What is that?
So, I think this is where we can probably take notice where, like how you say, one at a time, do the square first and the triangle, then the
Yeah.
other. Right?
So this is where you reach into the tools you've already made. You already have code that makes a solid rectangle. You should have already had code from above here to make a little triangle. And then you have code that does this. You just pull all those procedures, copies of them, into this procedure. But then what you have to do is know which one to call. So this one's called first, that second, that third, and then we go back here again, and then in this pattern we'll go on and on and on. So give me some ideas as to how you would call these in that pattern over and over again. Like, what does the main procedure look like?
Square, triangle, I don't know what the third one is.
Well, it's the mechanism. So let's see, which one is this? This is 5, figure 5. Figure 5 is a lie. All right, so here's, let's see here, solid rectangle procedure, right triangle procedure, hollow rectangle 3 procedure. All right, this is in the main procedure. I have a variable called alternate count. And then I've got x index, because what's happening, if you look at this, the x is moving, so the x of this, and the x of this, and the x of this, I mean, they're all spaced the same amount. So all it is just an x moving left to right. by a jump. In fact,
It's still the 60.
it's still the 6, right? But look what I did with going back to the if, else if, else if. If alternate count equals 1 during this time through the loop, which do we call?
Rectangle.
Yeah, but if it happens to equal 2, or if it equals 3, yeah, hollow rectangle. And then, look at this. All we need to do is each time through the loop, we take whatever is an alternate count and what do we do with it? Add 1 to it. And what happens when we went too far?
Go back.
It goes back. So this is just a very simple way, you know, call, if this variable is a 1, call the first procedure. If it's a 2, call the second procedure. If it's a 3, call the third procedure. And then each time through the loop, make that alternate count 1 higher so that we can ratchet to the next one we're calling. But if you go too far, just go back to the original. Oh, yeah. How are you going to do that?
Just
Start at 81.
Well, are there any loops involved here? Yeah, you could do this with loops, and so this is the thing, is this is the topic of, I think, next week. I'm going to, well, so the idea here is that if you know a little bit of trigonometry, this is a breeze. How many people have not had trig yet? 1, 2, yeah, okay, so.
Just a little.
What I'm going to do is teach fundamental trig from scratch in a way that I think you'll really like. I mean, I've never had anybody complain, and I've heard a lot of, wow, that was simple. And so next week, I'm going to show you how to draw circles with just a little bit of trigonometry. But this week, what I'm going to have you do is not use any loops, not use any trig, and you're just going to plot each of these points by hand.
So by looking at the picture itself, looking where like A1 is and 2 and 3.
Yeah, although as I'm looking at, okay, I don't see the lines, but the lines are there. So what you'll do is you'll zoom in and estimate where the X and Y coordinates are of each of these. In fact, let me show you the solution for this one. This is what they call brute force. And of course, this is a lot of copy and paste. Just get one of these to work and then copy and paste, blah, 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 blah. And just estimate. What's happening is that the grader is designed that if you're within half a point either way, or half a coordinate or half an integer either way, it'll say you got it. So you get as close as you can, but you don't have to be like dead nuts on. And this is to prove a point that you could do it the brain dead way, the hard way, but that's what you actually use your brain for, is if you know a little bit of trigonometry, you can get rid of this and just with this much code, just draw the circles. All right, any questions before I put you in the lab? All right, rest of the evening's for lab. I'll be back in about 10 minutes.